Your application is down, the first command you try to run is curl server and the port number. Press enter. Nothing happens. We are still waiting. We don't see any kind of response. Also, we did not see any error. Just waiting. What do you guys think? Is the application down? Maybe. Or maybe something else is wrong. For example, our Docker is broken or Kubernetes is broken, firewall, DNS, network. How do you know what exactly is wrong here? Most engineers immediately jump into the application logs. But here's the problem: the application may never have received the request, not even a single line or a log file, because before HTTP happens, something else must happen first. A tiny conversation, 3 packets in less than a millisecond, called the TCP Three-Way Handshake. Today, we will slow that particular conversation down, watch every packet, break it, fix it, and understand why production systems fail before your application even gets involved. If you are new to my channel and liking this particular series, comment networking and also try to subscribe to the channel and share it with someone who is preparing for DevOps interviews. All right. Now let's try to start with building the environment from scratch. I am going to jump back to my terminal. In the terminal, I am going to run a simple HTTP server using port 8080. Press enter. Nothing fancy here. It's a simple web server. Now let's try to open another terminal and verify if the curl request is trying to respond. It works. Also followed by, let's try to check the ports real quick. I can see this particular Python is running on this particular port 8080. This looks perfect. The application is alive. The operating system confirms it's listening. Everything is healthy so far. Now let's watch what nobody normally sees. I am going to run this particular command sudo tcpdump -i any port 8080. This particular command captures packets. Normally, millions of packets move around. Today, we are only interested in port 8080. Press enter. Now, let's jump back to the terminal and I'm going to run this curl command once again. As soon as we run, immediately TCP dump starts printing packets. Watch this. We have multiple different packets here. This is what actually happens before HTTP or HTML, JSON or APIs. If you look here very carefully, flags of S, this packet is called SYN. Imagine you are calling someone, you are trying to dial the number, you are not talking yet. You are asking, can we even talk? That's exactly what SYN means. It's simply saying I am requesting a connection, nothing more. Followed by, we have a second flag s dot. Now the server is trying to answer here. Sing acknowledge. Imagine someone picks up the phone, they say, yes, I can hear you. The server isn't sending HTTP yet, it's just confirming I am ready. Followed by, we have a third flag dot. Now the client responds, acknowledge. That's basically saying like, perfect, let's begin. Only now does the TCP connection exist. Everything before this was simply introducing two different computers. Only after this particular handshake does the curl will send the HTTP request. That will surprise many engineers. They think curl immediately sends get request. It doesn't. Finally, if you see here, it doesn't. TCP always comes first. Now let's try to understand the production mindset. Imagine about troubleshooting an application. If TCP is failing, HTTP will never start. If HTTP never starts, your application logs stay empty. That's why checking logs first can waste an hour. Sometimes the application never even knew someone tried to connect. Now let's try to break everything. First, I'm going to do Control C here, followed by I am going to check the TCP dump. We are trying to track the packets here. Finally, I'm going to run the curl request. Here I see an error, connection refused. Did TCP fail here? Yes. What packet is missing? Let's check that. Now, if you look here, I can see flag S. I will try to run this once again and check the TCP dump. You see, it stuck on the sync request. We do not see any other request. I'll try to run once again. Same error. The server never replied with sync acknowledge. It stopped at this particular request because nobody is listening. The operating system immediately rejects us. This is exactly what we learned in the last episode. Connection refused. Now let's do another interesting incident. Let's check that how it will try to respond. So here I will try to run the application. Before running the application on port 80, I am going to drop that particular port from the firewall, followed by I am going to start this application. Right now it is running on port 8080. Then I am going to start the TCP dump, and finally let's try to access this application. All right, I did not get any kind of output. Now let's jump back to the TCP dump, and if you look here, this particular application is, let's say, trying to say hello hello multiple times, but there is no one to respond. It is not accepting the connections because the client keeps asking for connection, but the server doesn't respond because we dropped that particular firewall port 8080. As soon as I try to allow that, let me do that real quick and try to do the curl once again, we get the response. And if you look at the output here, let me clear this and do it once again so that it would be more clear. Jump back to this, and if I run this and check the output, you can see we got the acknowledgement s dot, and also we were able to run this get request. So this is how the real troubleshooting looks like. This is how real troubleshooting looks like. The sync acknowledge never returns in our previous scenario where we were seeing only SSS. That's exactly why timeouts take longer. Now let's try to talk about a real production incident. For example, we have a payment service that was unable to connect to the Redis. Everyone blamed Redis here. Redis was not the problem at all. The firewall was. The application never reached Redis. Redis logs were empty because, as we discussed, if HTTP is not working, application logs will be empty. There was nothing to debug because the TCP handshake never completed. The outage had nothing to do with the application code. It failed before HTTP even existed. Let's try to recap what all we've learned today. Always remember this. TCP is like TCP is like introducing two different people only after they acknowledge each other. Like we see in this particular diagram, the real conversation begins. So next time, if curl hangs, don't immediately blame the application. Did the TCP handshake complete? That single question can save hours during a production incident. Before we finish, in the next episode, we are going to answer another question that every DevOps engineer should know. How does HTTPS actually work? We are going to go beyond the padlock icon which you see and understand what really happens when your browser connects securely to a website. We are going to inspect real SSL slash TLS certificates, verify them from the command line, understand why certificate validation fails, and see how expired or misconfigured certificates can bring production applications down. If you ever seen SSL errors during deployments or production incidents, you don't want to miss it. If you enjoyed this episode and learned something new, please hit the like button. It really helps the series reach more engineers who want to learn networking through real hands on labs. Subscribe if you haven't already, and let me know in the comments which networking topic you'd like me to cover next. Thank you for watching. I'll see you in the next video.